Welcome everyone to Orlando Python for May of 2022. This month we are going to take a dive into PyScript, which was just released at PyCon from Anaconda. And just as a general overview, it allows us to write Python in the browser natively, just like we would be writing JavaScript. With that brief interview or introduction there, let's dive in. Now, Python in general is like many other languages. It is Python itself is not a compiled language, but everything in one way or another compiles down the tree, but eventually to ones and zeros that we as humans can't read. You think of a traditional language, the compile step is more visible to the developer. Think of C, C++, Java, Swift. Most languages are compiled. Python itself is not a compiled language. It's called an interpreted language, which mainly means you as the developer don't need to worry about compiling. And coincidentally, it's also not a typed language. It's not a strongly typed language. And this puts Python into a very similar position in the development ecosystem as JavaScript, because neither one is a compiled language, neither one is a strongly typed language. It's fairly easy to go back and forth between the two. Certainly easier than moving over to a compiled language in a lot of cases. But Python does compile, and that it uses something called just-in-time compiling, which allows it to have that dynamic nature. The default is called CPython. So your Python code, when you run it, gets converted into C, which then gets converted dynamically to there's a bytecode, then assembly. No, it's Python, bytecode, C, assembly, and we get down to machine and binary. Now, what PyScript is doing, it too has this compilation chain, but it enables Python to do something that it's never been able to do before, and that is run natively in the browser on client machines. Traditionally, if you've wanted to have Python running in the browser, it wasn't really running in the browser. You'd either have to do some weird transcompilation, and it's actually just running JavaScript, which is, we're kind of going to see that a little bit today, but that's not exactly what PyScript is doing. More likely, maybe you'd be writing some Python code and it would have to send it out to a server that itself is running Python. So you have to be connected to some backend to write Python in your browser. This is something that you'll see with web consoles, VS Code, the online version, Python Everywhere, any of these sort of write Python in your browser. They almost certainly are relying on some kind of Python server backend. But that is not what PyScript is doing. PyScript compiles all the way down, but instead of getting onto machine, instead of taking the normal path, it is compiling down to something called WebAssembly, which is a relatively new language, being only officially adopted in 2019, and it has major browser support now. Now, WebAssembly is there to act as a compiled target for C and C++. Which means that you can write some really, really fast code, almost like it would be running outside of a browser on your machine. It's running significantly faster than JavaScript, because WebAssembly, coming from C, C++, is a compiled, strongly typed language. And compiled, strongly typed languages will always, or I'm going to like 99.999% of the time, will run faster than a just-in-time and weakly typed language like JavaScript or Python. That said, this tool, the tooling is relatively new and still being built. And as we'll see a little later on, still has room for improvement, but this is a fantastic start. Now, WebAssembly, we can't just write Python code and turn it directly into WebAssembly. Because remember, WebAssembly is a compile target, and Python natively doesn't compile, at least, again, from the developer's point of view. We need to have something to convert our Python code into C. Well, what do you know? Python has CPython. And that's where our first Python project comes into play, which is Pyodide. Pyodide is specifically taking CPython. You can write Python. It's a port of CPython that instead of compiling to specific machine's flavor of C++, it is taking that, getting it into a form that another library called Emscripten can take, and Emscripten is what takes the C++ and converts it into WebAssembly. There's a lovely little chart here. We can get a little bit of preview of what PyScript is going to do for us. But you can see at the very bottom here, our deployment target is WASM, WebAssembly, which goes through CPython, or this version of CPython designed to work with Emscripten. Now, Emscripten is primarily designed to work with C and C++, but you can use Emscripten with any language that can work with LLVM. This is a little more technical than what we're really going to get into here, but if you want to, you can. And this flavor of CPython that is created and maintained by the Pyodide project, you can think of it as just any other flavor of Python runtime. We have Jython, which converts your Python into the Java runtime. There's Iron. I don't think Iron Python is not officially supported anymore, I don't think, but that made your Python code run and operate with the .NET family of languages. There are a handful more, like one that converts it into Rust. In addition to, there's other kind of flavors like MicroPython, kind of off to the side a little bit there, but you can think of all of these as different flavors of runtime that your Python code will transcompile to, that will run on top of. And Pyodide has a flavor of CPython that is doing essentially that. Now, on top of that, before we get into PyScript, I just want to show Pyodide working. They have a REPL here, and maybe you've probably seen the Python REPL loaded in a browser before, but unless they were doing something like you can write Python code, but we're actually going line by line and converting into JavaScript to make it run locally. Or if you've seen this before and it was just sending off a request off to some backend server to make it work and then just printing out the result. That is not what is going on here. We can actually inspect our page. We can see our network, and this is everything on the page that was loaded. So the raw HTML, they use some jQuery and some Unix formatting to make it look like this, but then it's just the Pyodide WebAssembly and the connecting JavaScript file. And we can write Python here. We can create functions, anything that we want to. Doesn't really do anything, but I can type foo 4, prints out 4. And notice we're not having any other calls out to some external system. This is running locally, and as long as you do trust that this is running on top of WebAssembly with this asm.js script here, it's not being transcompiled. This is just running Python on top of converting to C Python to script into WebAssembly as we type it. That's pretty cool off the bat. So that's great. Pyodide allows us to write Python in the browser, or more accurately, it allows us to execute Python in the browser. So where does PyScript come in? PyScript, as we see, sits on top of Pyodide. Now, when you are using PyScript, you will not be interacting directly with Pyodide. This is the equivalent of starting to write Python files, myfile.py, and then running with Python, as opposed to trying to run everything through a REPL. You're not interacting directly with Python on a line-by-line basis. You are now executing and interacting with a web page. And the coolest thing that PyScript does is it allows us to write Python embedded in HTML files. That is by far and away the biggest thing that this project does for you. And that is really cool because now, from a developer's point of view, you can write Python where you would write JavaScript and how you would write JavaScript. Now, the crazy thing here, me personally, is if you are aware of the history of Python, back in the 90s, when the first browsers were coming out, the Netscape browser around then, they created JavaScript as a language to enable interactivity with HTML pages, which had already existed, by the way. But before they did that, as the story goes, one of the developers went to Guido, the creator of Python, and said, "Hey, we would love to use Python as the browser language. The one thing that you need to change, just because of how we have architected everything, we can't have this white space thing. You need to add curly braces or something else. We just can't have this white space thing going." And I'm sure you can piece together what happened. We still have white space in Python, and JavaScript is in the browser, and you can't write Python in the browser, specifically because of that white space thing. But as we'll see when we start taking a look at this, writing Python in the browser, we can see as part of some of their getting started, if we just go past the hello world, well, would you look at this? We are writing Python as you would expect Python to be run with whitespace embedded in an HTML file where whitespace isn't supposed to be important. I would say HTML and JavaScript are quite notorious for people's own preference on how things should be spaced out and indented. So it is interesting to see Python put into that realm. But that is absolutely what is happening here. And the other cool thing, just to get started with PyScript, is there is no installation process. All you need to do is just include PyScript as though it were any other JavaScript file that you're importing. I'm not gonna go too crazy into the weeds when it comes, in terms of web development, because this is a Python-based talk. But this is this is almost as simple of an HTML page as you can write, that it has more than just a single like H1 header on it. And the cool thing is this is itself a fully implemented file. I just copied it, and I will switch over the screen here to my code editor. Let's go to the full screen view here. So hopefully you should be able to see both the browser and the web page or the code editor here. So I'll make this look a little nicer. Pop that down. We can create a hello.html. Just paste all of this in there. And again, just taking a look at this, we got our HTML page. We have HTML on the outside. The head is where you would put your imports and other. It's actually kind of similar to the how you might lay out a Python file as well. All the imports, maybe your static stuff up top, and then all of your functions, classes, and whatever else is going on in that file down below. So all we need to do, we're not really going to be using the CSS in here, I don't think, but just kind of keeping these two for the style sheet and the actual JavaScript import. That's all you're going to need for just about, for most of the stuff we're going to do here. But we have this special PyScript tag embedded inside of the body. And we're just going to print hello world. That should convert it and just print it out on a page for us. I'm going to, I'm curious. No. Quickly do reveal in Finder and then open it back up in the browser here. So it's loading the runtime. So that was our WebAssembly loading up. And when you look at this, we got hello world. We can even inspect our page here to see what the final output was. We have our head almost exactly as we saw, but we saw that it deferred there. Not going to get into the semantics of that. But this is the final, rather more complicated looking, look behind the scenes of what's going on. But the result of our Python code got put here in this div, which is just hello world. And as long as you're most these days when you are writing front end, you're not really going in and inspecting everything in the JavaScript. You're probably writing with TypeScript. You're probably, well, you may or may not be using TypeScript. You are almost certainly using some kind of JavaScript front end, Vue, React, Angular, whatever the flavor of the week is. And you don't care what the output actually looks like. You just want to make sure it runs properly. And that's exactly what we have here. We printed hello world. We can take some of this down. As long as we are writing Python between these PyScript headers, we can write whatever we want. We can set this to be text, although my text editor here is confused as to my indentation preferences in this. We can write text. Save that. We can reload this page. Ta-da, same thing. We just assigned a variable. We're just writing Python. What if we wanted to do something a little more interesting? What if we wanted to, I don't know, import random and then have it print out, let's say let's do a list comprehension. We want our final text to be, let's say a space between, let's say rand range, random, yeah, I think it's rand range. Actually may need to, I haven't used rand range in forever, actually. Let's do Python rand range and just see what the syntax is. The one thing you'll notice is we don't have tooltips that we would have in our Python files in here.
I think what you have there will work. If you just give it one number, I think it's like 1 to that number.
Start, stops instead. Yeah, okay, yeah, that will work. I don't like it.
Oh.
Start. What do you mean? What do you mean the first one is optional? No, okay. That's why I like my built-in docs. They don't try to do things like that. Yeah, okay, so that will work. So this rand range is going to only pop out 1. So let's actually do before. Oh, I know rand range there for underscore in range 10. That should just give me an iterator that tries to pull 10 random digits between 0 and 9. Then we just put a space between them, and then we print out our text. Let's see. Reload. Okay, so we have exception here. And I forgot. Join expects these to already be casted, cast to strings. So we'll just cast a string. I actually hadn't seen what an error looks like in this before, so that's interesting. There we go. So we have 10 digits between 0 and 9 printed out here. So we can import from the standard library. That's pretty cool. Standard library, we can do a lot of things with the standard library. What if we wanted to have a third-party library? That is something that PyScript also allows us to do. Just getting back into the getting started. So you can see, similarly, they are computing Py down here. You can see that they support F strings. I'm actually not sure what version of Python they are. Oh, actually, well, let's assume that it's Python 3.10. That's what the Pyodide REPL was showing us. So yeah, we have access to all of our modern Python features, F strings, data classes, the walrus operator, even structural pattern matching if we so wanted to. Let's see. Okay, so now they're going more into there. Here we go. PyEnv. In this example here, we can see that they are importing third-party libraries. And again, you can do that with Pyodide, but it's not going to be as easy as, hey, let me just put this in the head. PyScript knows what to do with a PyEnv. It will go out and grab these libraries for us, have their WASM compatible versions loaded into the browser, and then we can use them. So let's just call this graph.html. Paste that in there. And just to quickly go over what we've seen, what we're seeing in the file. Again, we have our 2 standard imports. We have this PyEnv, which in addition to having the standard library at our beck and call, we now are going to import these third-party libraries, NumPy and Matplotlib. And they are now just available to us inside of our PyScript tag. Now, just going through, NumPy is going to do very quickly, because NumPy really relies on C for its speed. It's going to generate a random list of 1,000. I'm actually not sure what the range would be on here, but 1,000 random ints, which will be assigned to the x-axis, and then our y-axis will have another 1,000 ints. So we're creating random coordinate pairs, and we're going to graph them. And we graph them using Matplotlib. Friends don't let friends use Matplotlib directly, but that's what the example they have here. So we're going to create a figure. It's going to be a scatter plot using our x and y coordinates. And then Fig is, if you were running this on the computer, like in an interactive Python session, it would pop up a new window with your resulting graph. Let's see what happens in the browser. Now, just quickly over here, since I don't want to go back to the folder, I'm just going to change the name because it's in the same spot. loading the runtime, we have whatever was in there before. We had an H1 tag. It took a second to actually run everything, but it has now resulted in a scatter plot. And so many fun statistical analyses about average values and such could be made here. But we have a very simple and very low code, 1, 2, 3, 4, 5, 6, 7 lines of actual Python code generating a plot in the browser completely on the client side. Yeah, obviously after the JavaScript and once everything is delivered, the actual computation for this is on the client side. But you know what? Another nice thing the browsers do for us is cache. Now, why in the world? And you'll see that it's going to take a little bit to run this every time. It's kind of slow. If we were running this in with regular Python locally, it would be a little faster. If we were doing this with native JavaScript, yeah, it probably would be a little faster right now. So PyScript still has a little ways to go. This is a fantastic new offering in terms of, hey, you want to write Python in the browser, you can absolutely write Python in the browser. There are other examples. I'll actually show you their entire test suite to showcase what PyScript can do in a little bit. But why in the world would you want to do this? I think it's running slow. I could, if I was making a website that was going into production, why would I want to use this? Well, I'm going to tell you, you don't want to use this. If you're writing production, if you want something to go into production, you got to have a lot of people. This is not ready yet. This is still early stage. Again, Anaconda just released this a month ago, just over a month ago at PyCon. Pyodide has been around for a couple of years. WebAssembly has only been officially supported from all the major vendors and as a functional language for 3 years. This is all very new. This isn't like creating a Vue front end that has had the benefit of improving browser compatibility with JavaScript and runtime execution over for almost 30 years now, like 20, 26, 27 years. But it can only get better than this. Why would you want to use it now, though? The biggest example, like unless you just think it's cool and say, hey, I can write Python. I don't want to learn JavaScript or anything like that. The biggest legitimate use case I can think of for why you would want to use PyScript as it is right now is teaching people Python. The hardest thing in the Python ecosystem is, well, I mean, okay, everyone's going to have opinions about that. But if you are a teacher, if you are new to Python, the hardest thing is getting Python to work properly the first time around on your machine. And PyScript completely sidesteps all of that right now. There is nothing to install. Every machine has a browser. It comes with a browser. You can download your browser of choice. It's going to support WebAssembly. If you want to use Python locally on your machine, if you've been around the Python ecosystem for a while, you almost certainly have your preferred method that always works for you and has exactly the tooling you want. And it's very easy to forget what it is like to be a beginner. And when I've given workshops, family, friends, and just trying to get them started with Python in a way where they don't have to think about it is very challenging at times. Even just taking the OS out of here, you don't have to worry about any of that. New students that are concerned that they're going to destroy their computer, you don't have to worry about that with this, because when you're done, you close the web page and poof, you're done. There are some file IO things that you can do. I actually didn't even talk about that. I kind of went through that example, I believe. Maybe it was down further on, but no, I don't think they have it in here. Another thing that you can do with PyScript is, in addition to having things here, I think in one of these other things here, that same sort of thing that we did, or same kind of code generating some points, where you can put that in a Python file, and now in that pyenv, you can import local Python files. There is some level of IO that you can get, but you're not going to destroy your machine by using Python in this fashion. And for people who are just starting out, just having that peace of mind, knowing that, hey, I'm trying to, what is this programming thing? Is it going to destroy my machine? Even people that are in that mindset, if it's in a browser and it's not connected to any of their financial accounts or anything that they're concerned about, they understand, okay, when I close my browser, it fixes all my browser problems. It's not affecting my machine. And that is a great peace of mind to have. So we can dive in and see some more interesting examples. This is the PyScript sample project here. And actually, I think this is maybe the whole thing, but I'll get this up and running and built. I'm not going to go into everything that is happening here necessarily, but just so we can see some more interesting examples of what PyScript can do. So just going to go into the PyScript and PyScript.js, which is where we have our package.json that allows me to do npm install. Think of this like pip install from a requirements.txt file. So it's downloaded all of our dependencies. We'll then do, let's check the package here. So they have, it's either dev or start. I think they also have it in the README here. Yeah, so npm run dev. So that runs, this will actually start our server here. And I'll just go ahead and copy this over. But as soon as this is done, yep, waiting for changes, perfect. We can head over to our browser here, localhost 8080. And these are all of the built-in demos that they have to show off PyScript.js, or well, PyScript. And we can double check what each of these looks like by checking out the examples in here. So hello world should be more or less what we saw before. So this hello world is slightly different. You can see that outside of our PyScript tag here, they're writing just normal JS. We got a break in here. We can pop into here, hello world, and it's now computing a date time string, and it is now computed a date time string. Fairly simple. Can go back. REPL, yeah, we got, like we saw the REPL before, with just the Pyodide project, and they're importing anti-gravity. Okay, so actually I think they have a lot of their stuff put into the anti-gravity file, which is a deep cut for Python. But this is a completely local version of the Python REPL. And actually, it's yeah, now I remember. Now it's multi-line, so we can run that, and we can do classes and everything in here. I don't know, bars and ints, pretty basic. Let's go ahead and execute that. I believe we should then be able to do Google's an instantiation of foo, and I can set foo.bar equals 3. Really, really productive Python here. And if I print it, if we just print foo to the repr, there we go. We got an instance of foo. And if I wanted to, back in here, I don't know if, yes, it will let me do that. Perfect. Def, we can improve this repr function, taken self, and we'll just have it return something that would be more interesting. Foo bar equals, and actually I can make that look even better because of f strings, and it should be self.bar, just to keep the formatting there. Oop, if we run this again, oh, maybe not. Actually, kind of surprised by that. Maybe overloaded it. Anyway, we got a Python REPL running locally in a browser with PyScript. And again, Python file, very short. Yeah, and then anti-gravity is the thing that's doing kind of the heavy lifting here for this particular web page. But the nice thing there is you can see that we have REPL, or here we go, REPL and REPL2, which is doing things a little, it's going to make it look a little nicer than what we have here, at least according to the description here. And they can do that pretty easily because they are able to import this local antigravity.py file and share it between these two different instances, which is exactly what you want as a developer. Now to some of the more interesting, complicated things that they have on here. Some of these I've been able to get working, and others not so much. So we have our matplot generator here. I think D3 viz I couldn't quite get working, although I couldn't quite tell. Oh, okay. So this one did get working. I'm sure they left showing this one off because it's an instance where PyScript was a little faster than JavaScript, but Rod, in the same, from my own experience, friends don't let friends use matplotlib directly. I'm going to say friends don't let friends write D3 directly either in the JavaScript land. Like this one is d3.html. So a little more interesting here. You can see that they're pulling in D3 JavaScript version and the PyScript version and the code that we're going to see down here. So we can see that this is the JavaScript code that they are using to try to generate that. And down here, this is the PyScript equivalent. Yeah. This isn't a JavaScript talk, but this is a pretty interesting comparison. I'm sure there's something going on here. If I were to inspect, maybe there's something my browser is blocking. Yeah, Descript does not. Yeah, so this, we're not going to get a good example because something is going weird with accessing the D3 import. But just if you want to use this as a reference, JavaScript code, PyScript code running side by side. Let's see, what wasn't, I think it was Boko was the one that was borked down here, and I may just run it in a different browser. Failed. Okay, so yeah, this one is borked because they're referencing from the Boca CDN that doesn't exist. I'm curious. Let's actually fix that. So Boca CDN. Embedded content. You got to have the scripts here somewhere. maybe first steps. Oh, no. Right. They did something. Never mind. Right. Boca is a Python thing, and they have somewhere in there they were trying to import the JavaScript properties, and it's just not loading. Anyway. Not as interesting, but you can see that we have an interactive slider on here. At the very least, PyScript is able to interact and respond to input events and update these elements on the page. Not nearly as interesting as the graph would be, but still, yes, that wasn't the ones. I'm curious which ones in here are still going to work if they were built with Boca or not. Panel k-means. That one took a while to load, probably because okay, yeah. So they're using async IO in here, Altair and pandas. There we go. So I think this is a great example because yes, this is a dashboard. We can go in and we can inspect the data. This is a Python data or a pandas data frame. And this is more or less how you might be able to go through it in, say, a notebook, a Jupyter notebook of some variety. We have the graph up top that was generated with Altair. They're even doing k-means, or they're doing k-means clustering on this as well. And all of that is written in Python in this HTML file. But you saw how long it took to load. And yeah, you're crunching some data. But at least in this particular example, we weren't sure if it was still running and loading properly or if something had failed. Users nowadays, they need to see something. A web page that isn't at least mostly loaded within, let's say, 3 seconds, people are going to think your website doesn't work. So it's cool that it does that PyScript and Pyodide and WebAssembly can do these things in its current state. Again, this isn't trying to make it the most lightning fast screaming thing, nor is it meant to, like, this is an example. This is an example of the kind of thing you can do with PyScript. And there's still tons of room for optimization and working to make it fit the rest of the ecosystem. But would you write this for a production website today? Not yet. All that aside, this is still so freaking cool. It's Python without curly braces, running natively, and all we're doing is loading up an HTML file locally in the browser. Even doing something like this, you'd be crazy to write this nowadays, even in JavaScript, embedded in an HTML file. You would be in some sort, it'd be in Vue, React, whatever, to make this a far more complicated development environment. Just imagine what this is going to look like in however many years when this really takes off and we have those kinds of front-end building libraries revolving around Python, Pyodide, WASM, like the JavaScript ecosystem has now. That's going to be a really cool thing to see.
Michael.
Yeah.
Taking a little bit that note about how far can we can Anaconda and others can take this PyScript. Do you think that it could challenge the supremacy of JavaScript on HTML?
I it's an interesting question, because I can see it as a I don't want to say competitor. Like this isn't even like a competition between languages. This is, and again, we love Python here. Not everyone loves Python, and that's okay. You're allowed to have opinions and use cases, but this is special for Python. Anecdotally because of that bit of history, but Python has grown in popularity, because it is so easy to use, because of the in a large part because of the scientific tooling that has come out in the last decade, but also because of projects like this that have enabled people to learn Python and, to a reasonable degree, run it in more locations than just about any other language. And the fact that it is now as easy as it is to write some basic Python code in an HTML file, load that into your browser and get something that looks like this, I think it is looking really good. It's going to be a long time before PyScript and Python can really attempt to compete, I suppose, with JavaScript. But I don't think JavaScript is going anywhere. The learn one language and run everywhere mentality is very strong. But and you can take a look. JavaScript is a browser language, and people who are really good at JavaScript created Node so that they didn't have to learn another language to write a backend. That's kind of you can also see that with Swift. There are Swift backends, and I've given a couple talks on that as well. Even though if you learn Swift, you're writing an Apple app or an iPhone application, but it can be on the back end. Python was primarily a back-end scripting language and has just grown organically to cover more and more domains. I don't think Python is, I personally do not think that Python will supplant JavaScript as the largest and best supported language for the browser, because JavaScript was built for the browser. But we're getting closer to a time where JavaScript isn't the only choice if you do want to write a front-end application for the web. And I think that the more options you have, the better, because everyone has their own opinions. People have, I'm more comfortable with this. I prefer this style of syntax and these language features. I don't think that there's ever, I don't think choice is a bad thing.
All right, thank you.
Yeah. Another maxim is Python is the second best language at everything, which is both a dig and a glowing review of Python. And this is just another instance of that, I suppose. The cool thing that we love Python here. We're Python meetup. We probably most people here are either interested in learning, do it for their job, or do it for fun. We like it in some way. The WebAssembly and Scripting that Pyodide and PyScript are built on top, that are built on top of, are compatible with a lot of other languages. Again, anything that compiles to C, C++, or to the LLVM. You can compile Java, C#, Swift, a ton of languages down to WebAssembly. And once it is in WebAssembly, what's going on behind the scene here is WebAssembly is just a language that is built into all the major browsers nowadays. And JavaScript then, the front-end JavaScript calls a WebAssembly API from the JavaScript, say, hey, I need you to run the following code that is in this WebAssembly file. Here's the function, here's its inputs, give me the resulting output so I can put it on the screen. And that WebAssembly is pretty much always going to be faster than JavaScript trying to do it in pure JavaScript. There are websites and services that are already doing this. AutoCAD. If you pull up the web version of AutoCAD, hey, well, there's a web version of AutoCAD. In case you didn't know, that's a crazy modeling and design software. This would be like having Photoshop in the browser. I wouldn't be surprised if there's currently Photoshop in the browser either from Adobe. But WebAssembly allows you to do that. At least as far as AutoCAD goes, their front end is written in a JavaScript web front-end language. I'm not sure which one, but it is written in one of those. But all of the computation and internals of the AutoCAD system is now just is converted to WebAssembly. And the cool thing about WebAssembly and Inscripton is you don't have to write it specifically for WebAssembly and Inscripton. It is merely, nowadays, it is just another build target. When you're in your IDE, like if you're in Visual Studio, you have this giant C++, or whatever language project, and you need to compile it to work on, run it in Azure, here's a .NET, I need to compile it to X. WASM WebAssembly is just a new target. Compile, okay, now I have it to run on Windows, and I have this version to run in WebAssembly. And then you just build a new front end for it, and poop, there's your there's your AutoCAD. It's still WebAssembly is still very new. It is still getting a lot of adoption, but when you can make it as easy as, oh yeah, and also have it compile to that thing over there, it makes the web faster. Now, certain things are not going to be conducive to that. You're not going to be doing a lot of machine learning on your client's machine. You probably don't want to, because it will absolutely tax their. So there's still a big use case for having backend systems as they've traditionally been. But if your code is going to be faster just running on their local machine, and you need it to be very fast, like an AutoCAD sort of setup, WebAssembly is there. And once Python is as easy to use in that type of environment as, oh, here's another build target, we will start to see more applications being written in Python. We can already use PyScript to put in HTML files, and at least as far as getting started, and especially introducing Python to people who've never used Python before, I think that is a great first step. Yeah, so this page is still churning. There we go. 3D interactive web visualization. Average radius over the course of the day. I'm sure this will, yeah. Again, all using Python. This one is panel deck.gl, using a lot more third-party libraries to make map. This is done in Mapbox for the final, but all of the code, it's not JavaScript, it's using Python. Ta-da! No, I think this is a nice lengthy introduction to not just PyScript, but I guess where this came from and where it can go. I am very excited for this, and I know a lot of other people in the community are as well.